So now that you have a transactional data lake, now how do we unlock insights using matrix, right? So I want to know, like, for example, how many commits are happening on an hourly basis? How many are happening on a daily basis? How many are happening on a monthly basis? For each commit, what does the write look like? How many writes are happening? How many insert, update, deletes, right? I want to see how for each particular commit, what does the upsert time look like? For each commit, is the upsert time increasing? Is it decreasing? What's the graph look like? I also want to see these insert, update, deletes are touching which partition. So which partitions are being affected most, meaning the hot partition, right? Are my data going too much into the old partition or a new partition, right? I want to unlock all these insights. And to unlock this insight, we have to ingest these matrix to derive value out of it. So for learning purposes, we are going to use Elasticsearch. We're going to spin up Elasticsearch locally using a Docker Compose file. And then we'll have a sample Hudi job, which will write data into a Hudi locally. And all these metrics are broadcasted to HTTP callback URI, in which case this is our Flask backend, which will receive the events and is going to ingest the data into the Elasticsearch. Here you can see a sample Kibana dashboards. As you can see over here on the top down. You have an ability to filter down based on the table name. So for example, I am interested to see the KPIs for the Hudi table called employees. I can click on that and all the metrics would be filtered for that particular table. Here on the top, I see the average writes, the average insert, the average updates, deletes happening. I can also see for each particular commits, what does the file size look like in bytes, of course. So this gives me a good idea about that. I can also dive deeper into, for example, for each particular commit, how many inserts are happening, or how many updates are happening, or how many deletes are happening. So I get an idea more about my workload. I can also dive deeper into partitions. So for example, I can see, okay, my inserts or my updates or my writes are touching which particular partitions, right? So I can identify that through these graphs. I can also identify the upsert time. So I can see for each particular commit, how does the upsert time look like? Are they increasing? Are they decreasing? Is it flat? So this gives me idea about that as well. I can see how many commits I'm receiving on a minute level. I can see how many commits I'm receiving on an hourly level. And of course, you can add more and more KPIs based on your use case. So yeah, let's get started then. So the first step is we need Elasticsearch, and we're going to spin that up using Docker Compose command. So first, start by cloning the repository. Here you can see the command git clone the URL. This will clone the repository. After that, do Docker Compose up setup and then Docker Compose up. I've already done that. As you can see over here, my Elasticsearch stack is up and running. Then head over to localhost 5601. When you go to localhost 5601, it will ask you for a username and password. The username would be Elastic and the password would be change me. So make sure that your Elasticsearch is up and running. You can also verify that by going to localhost 9200, and hopefully you should see this message over here. Now the next part is, let's take a look at a simple Flask API which will receive events when any writers are trying to write data into the Hudi. The way we will broadcast these events from the writers would be through HTTP callback URI. So let's take a look. At the Flask API. The Flask API is very straightforward. As you can see, you can also convert this into a Lambda function if you want to try this on AWS, right? So, but again, here we define the username, the password, we define the index name as Hudi, we define the URL for the Elasticsearch. Since I'm running it locally, it will be localhost 9200. I have a very simple route, and all this route does is it will receive the event from the Hudi, and then it will add the ingestion timestamp. And then all it does is basically performs an insert operation on Elasticsearch. Again, the job of the API is to insert data into Elasticsearch. Now your regular writers can write data into the Hudi, and using HTTP callback URI, we're going to push all the events to the Flask API, which will insert data into the Elasticsearch. Let's take a look at the entire process. Over here, we define the imports, pretty straightforward, right? We create a Spark session. I'm using Hudi 0.14, okay? Straightforward here. Again, the entire exercise notebook is readily available, so please do not worry about the code part. Okay, so over here, what we are doing is these over here. As you can see, we are using Hudi write commit callback HTTP URL, and the URL is over here. which is where our Flask API is running, right? So anytime, the writers are writing data into the Hudi, it will basically forward the event to this URL, and the URL will receive the event, will deserialize the JSON, and will insert into the Elasticsearch, okay? Over here, as you can see, I have a simple Python function which will generate some fake data points. Now here you can start inserting data. So here we are inserting about 100 sample into the Hudi table. Here we are inserting 1,000 sample, and then here we are inserting 10,000 sample, and more than 10,000 samples here, right? And then we are basically deleting some data from Hudi, right? So what we are doing is we are simulating here, oops, the microphone. So we are simulating that we are inserting some data, we are updating some data, and we are deleting some data. Now what should happen is these events should be broadcasted to the Flask API, which will receive the event, and we should see some data on the Elasticsearch. If I now share my screen again and I go to Elasticsearch, you should be able to run this command, get Hudi underscore search. So if you do this, as you can see, these events are now flowing into Elasticsearch. So here you can see, we see the commit time, we see the table name, the base path, and the Hudi write stats, which includes number of writes, number of deletes, number of updates, which partition it was, what was the file size in bytes, how much time it took for creating that, how much time it took for upsert, etc., etc. So all the information you are going to see over here. Now what you can do is, I already do have a dashboard here. If I refresh, as you can see, all these KPIs are now I see that on Kibana, right? For example, here you can see how many write happened, what time it happened, etc., etc. So to add a visualization, you can head over to dashboard, right? And you can of course create one. I'm just going to show you a sample. So click on create dashboard, create visualization. And here what you want to do is, let's say for example, I want to see the commit. So here you can see, the commit on the x-axis, and now you can plot against any value. For example, let's say I want to see, total number of inserts that are happening for each particular commit, right? So I can come here, I can remove this one, search that, and simply drag it over here. And then over here, as you can see, I can click here and I can probably click on average. So I can see for each particular commit, what is the average document inserted, right? So now you can start building all these dashboard, right? So all I want to do is show you the process, right? So if I head over to my dashboard, I just want to show you the dashboard that I have, which would be Hudi KPI. So this dashboard tells me, okay, how many writes are happening? What is the average number of writes, right? How many, basically, as you can see, how many inserts are happening, right? How many deletes are happening on the data lake, right? This graph over here shows me the file size in byte versus the commit time. So for each particular commit, I can see the file size in byte. So that gives me a very nice information about the file size. Also now I can see for each particular commit, what is my workload look like, right? Am I getting more inserts? Am I getting more updates? Or am I getting more deletes? I can take a look at that. Now remember in the exercise file, if I show you here, first we inserted 100, then 1,000, then 10,000, and then of course more than that. So it is pretty obvious that, right, as you're inserting more data, it's going to take more time to upsert into the Hudi, right? So here you would be also able to see a graph. So as you can see, this particular commit time, it took about 544, I'm assuming it's milliseconds, so it took about 544 milliseconds. And then as the number of records were increasing, every commit, the graph is going up, which means it's clear, right? As more records are being inserted, it's taking more time for to upsert into the Hudi. Here you can also see, again, since we are just playing with dummy data, but although I want to give you a big picture here, you can see like how many inserts are happening into what particular partition. So now this tells you, okay, are my inserts or upsert equally balanced across all the partition? Are they touching old partition? Are they touching new partition? Do I have a hot partition here? You can basically get all these information through these matrix, right? So for example, if you have a streaming job, right? So now you can see, okay, every minute, how many commits are happening? So here you can see on an average, I see about 3 commits happening every particular minute. right? So now you get an information, okay, every minute I'm getting 2 commits, so which means in an hour I'll be having this many commits, in a day I'll be having this many commits. So you can have a lot more information, right? Is all I want to say. Here you can also dive into an hourly chart. So here you can see on an hourly basis how many inserts I'm getting, how many updates I'm getting, how many deletes I'm getting. And of course that you can dive more and more deep into that. All I wanted to show you is the big picture over here. So we saw a way on how we can, let me bring this back. So we saw a way on how we can ingest all these metrics when you're writing data into the Hudi, and then you can ingest this data into Elasticsearch. And now in Elasticsearch, you can search the data at a pretty fast rate. You can build dashboard using Kibana. Also, you have ability, for example, just want to show you really quickly. You have ability to, again, filter down, for example, here you can filter down a day ago, a month ago, on time frame, you can slice and dice on that. You also have an ability to share the reports. You can click on embed code, so you can basically embed the Kibana dashboard on your web app. You can also download PDF reports. You can download PNG reports. You can share this with your colleague, coworker. And if you have, let's say, 10, 20, 30, 40 Hudi tables, here I have a control action, so you can simply select all the tables. For example, I want to see the table employees, right? So if I click on that and of course click on update, I will see all the information about that particular Hudi table. So what this will help you is basically it will help you to understand your workload. It will give you much more deeper insight into your data lake. Thank you so much for watching the video. The complete source code, every single thing could be found on my blog section below. But if you have any further question, please do not hesitate to ask your question. And I hope the overall picture made sense. You can perform these labs locally on your computer. All you need is Docker and Hudi. With that being said, thank you so much for watching. And now one last thing that I would want to say, you can also basically, if you're doing this on AWS, so the Flask API would be converted into a Lambda function. You can use a function URL that would act as a webhook on your Hudi jobs. And then the Lambda function will again ingest all the data into Elasticsearch. And now you have these beautiful KPIs and dashboards. Thank you so much. That's all I have for the video. If you have any further question, you may use the comment window and ask your question. But until then, keep smiling, keep programming, and I'm going to see you in the next video.